Hello everyone, and welcome to the post-reading portion of the self-non-self discrimination lecture. Now, before you go ahead with this lecture, make sure you review these concepts because they will be important for understanding the lecture. In your lecture, I told you how Brecher and Cohn proposed that the activation of a naive lymphocyte requires signal 1 and signal 2, and that signal 2 comes from an activated helper lymphocyte specific for the same antigen. They actually also made another proposal. They said that the helper lymphocyte also requires two signals for its activation, and that signal 2, in this case, also comes from another helper lymphocyte. In other words, they said that helper lymphocytes must cooperate or communicate with each other before they can become activated. About 30 years later, Peter Brecher proposed the two-step two-signal model, which is a more accurate version of the original model and provided a possible mechanism for how cooperation between helper lymphocytes can happen. 20 years later, I came and made a slight modification to it and called it the quorum hypothesis. So, what is the quorum hypothesis? According to the quorum hypothesis, activation of CD4 T cells requires a quorum of lymphocytes. This quorum consists of B cells and CD4 T cells specific for the same antigen. What does the word quorum mean? Suppose there's a committee of 10 people and they need to meet to make a decision. For the meeting to happen, enough people have to show up so they can decide. We say that quorum needs to be established for the meeting to happen. So if the quorum is 50% plus 1, then 6 people must attend the meeting. Also, these people must obviously be in the same meeting to establish quorum. So how does this translate to immunology? If a single CD4 T cell sees the antigen, it will die because quorum cannot be established. However, if enough CD4 T cells are around, then quorum can be established. And how do you make these CD4 cells go to the same meeting? Well, they need to interact with the same antigen-presenting cell, APC. In other words, the APC acts as a bridge that connects multiple CD4 T cells, all of which are specific for the same antigen. And how do you make sure that only CD4 cells specific for the antigen of interest contribute to quorum and not other unrelated CD4 T cells? You have to remember that B cells are antigen-specific APCs. So, all of these CD4 T cells will be specific for the same antigen as the B cell. This is a visual summary of the quorum hypothesis. So, does the quorum hypothesis provide a mechanism for self-non-self discrimination? Well, I sure hope so because I want to get my PhD. Now, lymphocytes specific for a particular antigen are usually generated only one and maybe a few at a time. Now imagine there is a peripheral antigen called X. Because X is peripheral, it will not be expressed in the thymus, so you can't establish central tolerance to it. You need peripheral tolerance. Now imagine the first ever CD4 T cell specific for X. This CD4 T cell will leave the thymus, go to the periphery, and interact with X. In this scenario, quorum will not be established because there are no other CD4 T cells specific for X. This CD4 T cell will be deleted. And every time a new CD4 T cell specific for X is generated, it will be deleted. This makes sure that the body is tolerant to X throughout life as long as X is continuously present. Now, if there happens to be a bunch of CD4 T cells all of them specific for X, there will be a risk that quorum will be established. But there is another checkpoint. You need a B cell specific for X. The odds of having a B cell specific for this self-antigen X is extremely low because B cells specific for self-antigens are also deleted. So, quorum cannot be established in this scenario and tolerance to X will be maintained. Now, what about a foreign antigen F? Since F is foreign, it will not be present early in development. This allows the accumulation of F-specific lymphocytes, which allows quorum to be established when F is introduced into the body. This is a drug called rituximab. It is a monoclonal antibody that depletes B cells. It is currently used to treat autoimmune diseases, even those that don't need antibodies to cause the symptoms. Scientists still don't fully understand how rituximab works, and the quorum hypothesis is the only one that can provide an explanation. And I thought you guys might be interested to know that. Now we will discuss a very important concept: how foreign antigens that cross-react with self-antigens can break tolerance to these self-antigens. To explain how this can happen, we will go over an experiment performed by William Weigel. Weigel was able to induce tolerance to BSA in rabbits, and then he managed to break the state of tolerance by injecting HSA. BSA and HSA are both serum albumins, and they cross-react. This means that they share some epitopes. We'll make things simple and say that BSA is made of two epitopes, 1 and 2, and HSA is made of two epitopes, 2 and 3. So here's the experiment. If you inject a 4-month-old rabbit with BSA, you get loss of antibodies to BSA. However, if you inject a baby rabbit on the day it's born with loss of BSA, wait 4 months, and then give it more BSA, you find that the rabbit doesn't make antibodies to BSA. This was interpreted as the rabbit becoming tolerant to BSA. Now, if you repeat this last step, but you also give HSA around 3 months of age, and then again around 4 months of age, the rabbit makes antibodies that can bind HSA and BSA. This was puzzling at the time because the rabbit was thought to be tolerant to BSA, but giving HSA somehow broke this state of tolerance. Even more interesting was the fact that rabbits that received HSA were later able to respond directly to BSA, meaning that you can inject them with BSA alone and they will be able to make antibodies to BSA. We will go through this experiment step by step and hopefully it will make sense. First, let's talk about why early administration of BSA causes tolerance in rabbits. Since BSA was given in very high doses, the BSA disseminates throughout the body. This will decrease the ability of the lymphocytes specific for BSA to communicate with each other to establish quorum. Also, since the BSA was given early in life, the rabbit wouldn't have many lymphocytes specific for BSA. This makes it easier to establish tolerance to BSA. So how does the administration of HSA break tolerance to BSA? Before we go over this, keep the following in mind. 1. Lymphocytes are continuously generated. 2. When you tolerize the rabbit to BSA, it means that you get rid of the majority, if not all, the lymphocytes specific for BSA, meaning that the rabbit won't have any lymphocytes specific for epitopes 1 or 2. And 3, HSA and BSA both have epitope 2. If you take a BSA tolerant rabbit and you give it HSA, a B cell specific for HSA will take it up, chop it up into little peptides, and these peptides will then be presented on the surface of the B cell. This B cell will present epitopes 2 and 3, both of which are found on HSA. You never tolerize the rabbit to epitope 3, so CD4 T cells specific for epitope 3 will cooperate and activate each other, and they will also activate this B cell. This results in the production of antibodies specific for HSA. Since lymphocytes are continuously generated, a CD4 T cell specific for epitope 2 can come in and join the party. Since quorum is established, this CD4 T cell will also become activated. In the previous slide, I said that the B cell is specific for HSA. Since lymphocytes are continuously produced, you will get a B cell specific for epitope 2 that will bind HSA, ingest it, break it into little peptides that will bind MHC2 and go to the surface of the B cell. After that, CD4 T cells specific for epitopes 2 and 3 will activate this B cell, and antibodies specific for epitope 2 will be produced. Since both HSA and BSA have epitope 2, this B cell will produce antibodies that will bind both HSA and BSA. Now we will see how these rabbits can respond directly to BSA after having received multiple injections of HSA. Before we go there, keep in mind that now we have managed to get activated CD4 T cells that are specific for epitope 2. Imagine now you have a B cell specific for BSA. This B cell could be specific for epitope 1 or epitope 2. This B cell will take up BSA, process it, and present peptides on its surface. Since we have activated CD4 T cells specific for epitope 2, these CD4 T cells will activate this B cell, and this results in the production of antibodies specific for epitopes 1 or 2, depending on which B cell you activated. These CD4 T cells will also help activate a newly generated CD4 T cell specific for epitope 1. And by now, we have managed to activate all the B cells and CD4 T cells that are specific to BSA. Weigel's experiment and the quorum hypothesis provide a mechanism for how foreign antigens that cross-react with self-antigens can cause autoimmunity. This is seen in some cases, such as rheumatic fever, caused by group A streptococcus. An infection with streptococcus could trigger an autoimmune response against the heart valves, resulting in rheumatic fever. Another example is Guillain-Barré syndrome, which can occur after an infection with Campylobacter jejuni. The last thing we will talk about is a phenomenon known as epitope spreading. Epitope spreading is observed in some autoimmune diseases. When the disease starts, the lymphocytes involved are usually specific to one or a few epitopes of a particular antigen. As the disease progresses, the number of antigens and epitopes being recognized increases. This can be explained by the quorum hypothesis, because as the disease progresses, the responding lymphocytes will help establish quorum for the other lymphocytes specific for other self-antigens. Here is an actual experiment demonstrating epitope spreading in mice that are susceptible to developing autoimmune diabetes. I don't expect you to know this, but if you're interested, give it a read. Thank you for watching. Let me know if you have any questions, and good luck with the quiz.